Right, this video will go over the Windows part of the ICMP lab. But before we start, I would like to just point out that if you're watching this video at some point in the future, there's a chance that some of these commands may have changed and the video did not get updated, but that's fine. The things we're doing now will be very similar to what you'll do. You'll just run the commands that are on the lab sheet if you have a different set of commands. So depending on whether we're doing this lab remotely or in the class, there are slight differences in the commands we run. But this is the version that we do in class that I'm going to be going through right here. So essentially, like the intro video said, that was pretty awkward. My connection to my Windows just disappeared. There we go. So like the intro video said, we're gonna run these commands and see what happens. So first thing we want to do is start Wireshark on the appropriate interface. I'm using a VM for this part of my demonstration. You'll have an actual PC if you're in the lab, and we're gonna run traceroute 100 100 102 from our Windows command prompt. And what this does, well, actually, we're gonna see what it does. And we're going to see what the replies are. So the whole goal this week is to generate some traffic that is going to cause some ICMP error messages to be returned. And if this thing keeps dying, this is not going to work at all. And I'm not sure what's going on. Try this one more time. All right, so I ran the traceroute. If you look at what happened in the command prompt, if you look at what happened in the command prompt, it tells you the IP addresses of each router that saw that packet, and then finally the final host. So in this case, this was my first default gateway router. This was the next router it passed on its way, 254. It also went through .1, and then 100, 100, 102. So if we look at what happened, first off, let's go ahead and stop this so we don't get any more traffic. So if we look at what happened, we sent a ping request with a time to live of 1. You see the time to live of 1. If we go look in the IP header portion of this packet, we can see the time to live is 1. What that means is the first router is going to decrement that to 0 and then send us this error message, this time to live exceeded error message. So this is what we're looking for in this particular case. If we go down to the ICMP error message part, we can look at, see it's type 11, code 0. And then, as you hopefully remember, if you dig farther down into this Wireshark decode, you can see this is the packet that caused that error message to happen. So we sent this is the ping packet with the time to live of 1. That's the payload of this error message. So the payload of an ICMP error message, to restate that, is the IP datagram that caused that ICMP error message to be generated. So that's what we're looking for this first one. If you further analyze this data in Wireshark, if we go down a little bit, you can see this is the second packet that was sent with a time to live of 2. We got a time to live exceeded message from the second router on the path, which was 243.254. We go down a little further. We get time to live exceeded equals 3. We got this one from 192.168.243.1. And then if we go to the very end, you will finally get the echo replies from the end host. So if we look at the sources of these error messages, they match up with what we see in our command prompt. So that's what you should have seen for the first one. The next command is going to send a larger ping with the don't fragment bit set. So we're going to go to the command prompt. First off, before we do that, what you want to do now is you want to save your capture files because we want all these. So we'll save this one and we'll call it something like ICMP lab Windows 1 would be a good name for that one because that's the Windows side of the lab and that's problem 1. So then we'll restart our capture. and then we will send a 800 byte ping with a don't fragment bit set. So ping-f means set the don't fragment bit. We can use -L to specify the size. We did this in lab 3. And then I give you an IP address to try to ping, 192.168.253.110. So we'll send that ping, and we'll look at what happens in Wireshark. And what we see in Wireshark is we are sending a ping. I'm going to go ahead and stop this. Now I'm going to leave it running for now. We're sending a ping. If we look in the IP header, the don't fragment bit is set, which hopefully you recall means this packet cannot be broken into smaller pieces. The total length is 828 bytes for the IP packet, and what's happening is it's getting to a link in the network that I have set artificially small to cause this behavior. So if we look at this error message that came back, it's coming back from the router at 192.168.243.254. And it's telling us that the MTU of the next hop is 700 bytes. So we cannot send that 800 byte ping across that 700 byte link because we did not, we told it that it could not fragment our packets. So that's what we're looking for that one. There is an interesting behavior with Windows with this particular problem. If you look, it says reply from this first one. We got a reply. It says reply from 192.168.243.254. Packet needs to be fragmented, but DF set, which is true. But the behavior that's interesting to me is like Windows didn't even try again. So we get 3 more error messages, right? But we only ever sent 1 ping. And if I try to send that again, if I try to send this ping again with a DF bit set, it reports to me that it needs to be fragmented, but it didn't even try again. It's not sending another echo request. So I find that to be strange. Eventually this times out and it will send the ping again, but I would like, personally, if I was writing the code, I would always try the first time to send that. So again, don't forget, you want to stop your capture and save it. I'm not going to save all these because I don't need them, but you do need them. So save that, restart Wireshark, and let's move on to the next one. All right, this next one is trying to do a strict source route. We talked about IP options in the IP studies we did in Lab 3, and strict source route is a pretty much outdated option that you can use to try to force your packets to go a certain way. You can specify which host it needs to go to. So for this one, we're going to specify the -K option, and then I have some IP addresses on there. So let's go ahead and start typing the command out. Ping-K is the option we want, and then we have some IP addresses. And if we look at what it says 10.243.x.x, and then the lab sheet says for 10.243.x.x, use the IP of the host gateway. So this host has the IP address 10.243.133.2. So the gateway for this host is going to be 10.243.133.1. So the router for this subnet is what we want to put there. And then the next thing we want to put is 192.168.243.1, 192.168.243.1, and then the last thing we want to put is the IP address of your Linux host, which in this case mine's going to be 10.243.133.34. So what we're basically trying to do here is specify the path that this packet must take, because we're doing a strict source route. And this source route we have specified is not possible. So what happens is we try to send this packet and specify the route, and what happens is the router replies back to us. The router replies back to us and says, oh, hey, I can't send that packet that way that you want me to. So in this case, we got, lasted longer than I thought. I'm not sure what's going on. I have to figure that out. But Easy enough to get it back. So in this case, we got type 3, code 5, source route failed. And that happened because if we look at the datagram we sent in the IP options, if we look at the IP options in the IP header on the datagram we sent, if we look at the options, we have specified a source route. So we said essentially we said our packet can only go through these routers and it must go in this order. And that was not something that was possible to happen for that packet. So that's what the fourth one should have done. Sorry, that was the third one. That's what the third one should have done. Again, you want to save your capture. You want to save your capture file. And then we'll move on to the fourth one. The fourth one says ping 192.168.100.100. That is an address that does not exist in our environment. So we should get some sort of destination host unreachable message for that. Let's try that real quick. Remember, save your capture file, restart Wireshark. And then we will ping 100.100. That's not what it was. It was 192.168.100.100. And this is the last one for Windows, so I'm just gonna try to brute force my way through this connection issue I'm having that I don't know what's causing to try to finish this, and then maybe we'll see what's happening. So we ping this non-existent address and see if we get an error message. So we got a destination host unreachable message. So if we look at that, the ICMP type 3 code 1 host unreachable. So you'll again want to stop the capture and save that capture file. So that's what we're doing on the Windows side of things for this week. We have those 4 commands we're going to run to cause some ICMP error message to be returned to us. And it died again. Nice.